In this video, we're going to take a look at factoring quadratic trinomials using a method called grouping. I refer to these as harder quadratic trinomials. They're of the form ax squared plus bx plus c, and what makes them harder than other quadratic trinomials is that a is not equal to 1. So the multiplier with a coefficient in the first term will be something other than 1. Now, it doesn't matter what method you use when you are factoring. You've just got to be able to factor. There's several methods for factoring quadratic trinomials of this form. This one is called grouping. If you don't like it, find one that you like. Again, you just have to be able to factor by hand. You have to be able to do this, and it doesn't matter what method you use. So I'll look at the steps here, and then I will do two examples. Okay? So step 1 says compute the product of a and c. If you notice in the standard form here, that a is the coefficient in the first term and c will be the constant, which is the last term. Step 2, find the factors that I'll call f1 and f2 of ac whose sum is b. b is the coefficient of the middle term. So, step 3, rewrite the expression replacing the bx term with f1x and f2x. These are the factors you found in the previous step. The order of this does not matter. That's where some flexibility in this method. Okay? Step 4 is draw a vertical line between second and third term. That's just going to give you a little visual guide for what you're doing in step 5, which is to factor the first two terms using GCF, and then repeat that to do the same thing for the last two terms, which is factor with the GCF. Step 6 is a little fuzzy, okay? It's where some kids get a little confused. I'll try and put some extra focus there when I get there. It says to factor the two terms created using the GCF again to create the final answer. So you're going to GCF twice in step 5 and in step 6. Okay? They're going to use them different ways though, but again, they are both the GCF principle. Okay, so if we're going to factor this example where it says 10x squared plus 23x plus 12, I'll just run through these steps. Okay? The first thing you want to notice is that a, b, and c in this problem are 10, 23, and 12 respectively. Okay? So step 1 says compute the product of a and c. And in doing so, I see that a times c is 10 times 12, which is 120. Then in step 2, it says find the factors f1 and f2 of AC whose sum is b. Well, 120's got a lot of factors, so I'm just going to reiterate that you can in these types of problems. Go to your graphing calculator and go y equals 120 divided by x, and go to second table, and that's a quick way of listing the factors of a number. Okay? So I need the ones that add up to 23. I just scroll down looking, and I see when I get to 8 and 15, that seems like a great place to stop. So I could make the long list by hand, but again, you're just trying to get the answer in an efficient way. So going right to 8 and 15 via the calculator, totally legit. Step 3, rewrite the expression replacing the bx term with f1x and f2x, which is going to be derived from these two factors. Again, the order of this does not matter. So here I go. I will write 10x squared, but instead of 23x, I will now write plus 8x plus 15x, and then continue with the original problem of writing plus 12. Okay? Very big key thing here that we want to always talk about in math is the original problem is no different than the one I just wrote. It just looks different. 23x is still represented in the problem, but it's just split now. Step 4 is to draw a vertical line between the second and third term. Notice when I do this that I keep the sign of the third term with the third term. That's important. Now, this is where I've created two groups. The first two terms are a group, and the last two terms are a group, which brings me to step 5. It says factor the first two terms using GCF. Do the same for the last two terms, which means factor with GCF. So what does that give me? I notice that the GCF of 10x squared and 8x is going to be 2x. And to find the remaining factor, you would divide by 2x. I'm going to use the magic pen just to kind of conserve some writing. You guys should have this skill down pretty well by the time you get here and not need to see the writing. So that's going to give me, when I divide 10x squared plus 8x by 2x, I get 5x plus 4. And then I'm going to examine the last two terms and do the GCF. So the GCF of 15x and 12 is going to be 3. And then to find its buddy factor, you will divide both terms by 3 and come up with 5x when I divide 15x by 3, and 4 when I divide 12 by 3. Okay, now this brings us to step 6, where it says factor the two terms created using GCF again. Okay? Well, I hope you can see this here. There are, in fact, two terms. The first term is 2x times the quantity 5x plus 4, and the second term is 3 times the quantity 5x plus 4. Okay? Well, visually, you should be able to see that what's common in both these is a factor of 5x plus 4. It's a little fuzzy for some kids because this factor is a binomial. It's a set of parentheses, if you will. But I will, in fact, factor out the quantity 5x plus 4. And then I'll just try and give you a little more writing here with this, just for a second. And then I will divide each term by 5x plus 4 to find the other term. Now, this part I'm doing in black, you don't have to do. I'm just doing it to kind of show the example better. Okay? So if you notice, 5x plus 4 cancels here, and I'm left with 2x. And then the 5x plus 4 cancels here, and I'm left with plus 3. So again, you don't really need those pieces. If you can see them, great. Visually, you should be able to go from this line to that line. But you have to understand is I did, in fact, use GCF to go from one to the other. GCF in this term is 5x plus 4, and the GCF in this term is 5x plus 4. Okay, so it's a little getting used to, but once you get past it, you'll be generating these answers decently quickly. So speaking of answers, this is the answer. The quantity 5x plus 4 times the quantity 2x plus 3. I could check it with FOIL, which is 5x times 2x is 10x squared, followed by 5x times 3 is 15x, plus 4 times 2x is 8x. So 15x and 8x is in fact 23x, and 4 times 3 is in fact 12. So this answer is perfectly acceptable. Okay? So I'll give you another example of this. I think this next one's going to have a negative involved in it, which shouldn't throw me off too badly. And let's see what we have here when we're asked to factor 4x squared plus 13x minus 12. And in this problem, the values of a, b, and c are 4, 13, and negative 12 respectively. So in step 1, when I go to compute the product of a times c, it's 4 times negative 12, which is negative 48. It's not a real long list, but just to show you again how to maneuver this on your calculator for step 2, where it says find the factors of AC whose sum is b. We need the factors of negative 48, whose sum is 13. So I'll go for negative 48 divided by x in my y equals window. And then I'll go to the chart, and to get a positive number, I need the bigger number in the factor pairs to be positive. So I scroll up, and I see that 16 and negative 3 seem like a good combination for what I should be doing here. So my factors that I'm interested in are going to be negative 3 and 16. So it says rewrite the expression replacing the bx term with f1x and f2x, and the order does not matter. Just to make a point here, I'm actually going to switch this order. It makes the problem almost a little bit harder for a second, but I just want you to see that how working with this negative sign is done in this problem. So I'm actually going to go 4x squared. I'm going to go plus 16x minus 3x, which again, you notice, does not change the value of the problem because it's still 13x, minus 12. Okay? Now, I could have written here negative 3x plus 16x, but I just want to show you a little bit when the negative sign is over here, how to handle it. You don't really handle it any differently, but it's a good opportunity just to keep your eye on as it comes up in certain problems. Okay? So I'm going to draw my vertical line between the first, separating the first two terms from the second two terms, so between terms 2 and 3. And I'm going to, in step 5, factor the first two terms using GCF. So what is the GCF of 4x squared and 16x? It's 4x. And then again, when I divide by 4x, I'm in fact left with x plus 4. What's the GCF of the last two terms of negative 3x and minus 12? Well, if you notice, that negative means the GCF will have to be negative, okay? So it's the same rule we've always used, is when you're doing GCF, when the first term is negative, the GCF is negative. Now you can say, well, that's not the first term, it's the third term. Well, it is the first term of these two that I'm factoring. So what's the GCF of negative 3x and negative 12? It, in fact, is going to be negative 3. So be careful when you divide by negative 3 because the signs are going to do some changing. And that is going to give me here the quantity of x plus 4. Okay? So in step 6, it says factor the two terms created using the GCF again to create the final answer. So although I'm saying again here, it's not the same GCF. I'm just thinking, do GCF again. Well, I should notice that the GCF here is this thing that I'm seeing occurring twice, which is the quantity x plus 4. So I will take out the quantity x plus 4. Hopefully you're jumping right to the fact that the remaining factor is 4x minus 3. Okay? Hopefully the colors are helping you too. If you don't see that, just do what you've always done for GCF, which is once you establish the GCF, divide every term by the GCF, which here will cancel the x plus 4s, leaving me with 4x, and here, canceling the x plus 4s, leaving me with negative 3. So hopefully you will be able to do that in your head and not need that part of the problem. Okay? But if you do, write it in and take a look at it. Eventually you'll start seeing it in your mind's eye and not need it. So how can I check this problem? Good old-fashioned FOIL. X times 4x is 4x squared. And then I've got x times negative 3, which is negative 3x, and 4 times 4x is going to give me 16x. That combination makes 13x. And then 4 times negative 3 is, in fact, negative 12. So making this answer pretty legitimate. So this is the grouping method. Feel free to continue to practice it on examples. Use it. While you're using it, determine if you like it or not. You have to come up with a method you like. In the end, you might not like any of the methods, which means you just got to pick the least of all of the evils, so to speak, because you do have to be able to factor quadratic trinomials of this form. Again, what makes them harder is that a is not equal to 1. And you saw in this problem, it in fact wasn't. Okay? So enjoy, feel free to rewatch, and if you don't like it after giving it a good earnest try, pick another method and work with that. But you are responsible for being able to factor expressions of this form.